what's the other number? What should go down here? What do your notes say? Okay, find the proportion that says whole hypotenuse. What does this corner say? Okay, so you've identified that these are the two segments of the hypotenuse because that's what you did for your altitude. Which of these two is next to 9? Exactly. That's how we set that one up. So cross multiply, we have 12x equals 81. Divide by 12. You're going to get x is equal to 3 goes into 81 and 12, which is the same thing as 6.75 if you did a decimal. Now, if this is 6.75, Caitlin, how are we going to get y if this whole segment is 12? Well, I'm definitely going to put 6.75 here, but I need y. And I know this whole length is 12. And I know this portion up to here from here is 6.75. Right. 12, the whole, take away 6.75, gives me the y, which is 5.25. So I'm going to put 5.25 here. So from here, you're going to multiply, get z squared, and you're going to multiply 6.75 times 5.25. And then you're going to square root both sides. I don't know what that is. No. You know, you probably say, I don't know that either, but I don't know what this product is. Yes, where did I lose you? I cross-multiplied. With me? But I don't know what this is. So I'm just going to indicate it because I do want to know my answer was 5.95. So what would you do to get 5.95? What would you do? Multiply and then square root, right? Next question. 6. All right. 6. The only thing that I could do to kind of make these look different was rotate the picture. Did you notice that? So this is 90. This is 90. Oh, I'm really messing that up. All right, well, you get the idea. All right, so 6. This is 4. This is y, and this whole thing is x. And then they gave us 10, and they gave us z. So the first question is, who are the means? Name one mean, Brittany. Is the hypotenuse of the large triangle a mean? Z. Z is a mean because it's a large leg. Devin, what's the other one? 10. It is because it is the... Okay, what did I not give you? What are we not going to use? The altitude. So we're going to set up these proportions so that the mean are in the mean position. Let's start with 10. When you have the leg of the large right triangle, it's the geometric mean between what? Jeff? The hypotenuse, whole hypotenuse, which is x. And this part of the hypotenuse that's closest to it, exactly. Z is my other large leg. So it's going to be the geometric mean between what, Eric?
What was the question?
The geometric mean. We need to fill in these spots. It's the large leg is the geometric mean between what? Were your notes? Do you have your proportion written?
Yes.
Okay, so look at the large leg one. What does it say?
Says the leg of the right triangle.
Okay, but did you write the proportion?
Yeah.
Or okay, so what does this part up here say?
Whole hypotenuse.
Okay, what's the whole hypotenuse?
X.
Uh-huh. And what does this one say?
Second hypotenuse.
Okay, here's the leg. Which segment is closest to Z?
Y.
Exactly. This is not solvable at the moment because it's all variables, but look at this. We have 4x equals 10 times 10. We divide by 4. What's 100 divided by 4? Okay, so x is 25. So that means, let's come back up here. This means that my whole hypotenuse is 25. If this part is 4, and the whole thing's 25, what is this? 21. So now when I come over here, I need x, which is 25. I need y, which is 21. So we're going to have z squared is equal to 25 times 21. Now, I'm not going to multiply those. I'm going to square root both sides. And what are the factors of 21? 7 and 3. By the way, what's the square root of 25? So that's going to be 5. Are there two factors of 7? Are there two factors of 3? So they stay under 5 square root of 21. Other questions? You don't get what? Okay, what is the square root of 25? Exactly why it's out there. I could have broken 25 into 5 times 5. What was multiplied by itself? 5. Brittany. Mm-hmm. Yes, whatever was multiplied by itself exactly comes out on the outside. All right, I'm going to make sure that the teacher is here. Teacher's not here? Is that P? Okay. That'd be cool to be standing up here. All right, we are 22 in the book. 22 in the book. Oh, that's the application. All right, we got an architect. He's built an interesting house, and he's got this situation. This is the support post for the second-story roof, and they told us that this was 10. In the picture, they have drawn this to be 25. All right, and they say, so what mean did they give you? Which one? 10, which is the what? Altitude. So when we go to set this up, the altitude is the geometric mean, not between 25, but between the pieces of the hypotenuse, right? So if this is x, and the whole thing is 25, how do I get this? 25 minus x, just like we did up here. This was 25, that was 4. What did we do to get 21? Took whole minus part. So we're going to say x over 25 minus x. Now, yesterday when I did this, we went through factoring. We're not going to do that today. We're going to use the quadratic formula. So we're going to multiply these. So we're going to have x times 25 minus x equals 10 times 10. Distribute, you have 25x minus x squared equals 100. You have an x squared with an x to the first, which means we need 0 on one side. So if I add x squared, I like to keep my x squared positive. That's why I'm not subtracting 100. And I'm going to subtract 25. I've got 0 equals x squared minus 25x plus 100. Now, ax squared plus bx plus c equals 0 is what we need for the quadratic formula. A is with the squared term, B is with the x term, C has no x at all. So that means this is a 1. That means A is 1. B is the one with the x term. It's negative 25, and therefore C is 100. All right, you might want to put this in your notes because pardon? What red line? It's a 1. So you knew that that was 1. So they expect you to know the quadratic formula because this was Algebra 1. They're going to expect you to know this when you hit Algebra 2. There's going to be a lot of expectation that you know your Algebra 1. Remember, lots of stuff that we haven't reviewed. So we've got 2a. So now, what does this mean? This means we take the opposite of b. b is negative 25, so we do the opposite of negative 25 plus or minus the square root. Now we're going to put negative 25 and square it inside. Minus 4 times a times c, and this is going to be all over 2 times a. And this is what our x is going to equal. This becomes positive 25 plus or minus, when you square 25, negative 25 on a calculator, you'll get 625. Negative 4 times negative 25 is plus 100. Did I do that right? What did I do wrong? I put 25 instead of what? This should be what? 100. Let's see, this is not right. So anyway, so now this becomes minus, not 100, but 400. That's better. All over 2. So you've got 25 plus or minus the square root of 225 all over 2. Now, if you square root 225, you should come up with 15. What does this mean? This means that you should take 25 and add 15, divide by 2, and it says that you should take 25 and subtract 15 and divide by 2. So this is going to be 25, 35, 40 over 2, which is 20. This is going to be 25 take away 15 is 10 over 2, which is 5. So we get 2 x's. So when x equals 5, what does y equal? 20. If this were, and if I look at my picture, and I'm not sure we should be looking at the picture, they want to know, what did they ask for? How far from the front of the house is the support positioned? So we got a 5 and we got a 20. Does it make sense that because this is shorter, that should be the 5 and this should be the 20? Architects usually draw to scale. Is this helping at all? No? Brittany. 31, then I teach and I'll come back. So we've got archaeology. We've got some weird rock formation, I think. Is that true? Is that what we're looking at? Bottom line is you've got this picture. You've got this large right triangle with the altitude drawn to the hypotenuse. And they have told us that this is 3.5 and this is 1.84. It says, estimate the height of a stone figure. She stops when the bottom of the figure aligns with the bottom of the square and the top of the figure. Her eye level is 1.8 meters from the ground. She's 3.5 meters from the figure. What is the height of the figure to the nearest meter? So this is number 31. So what is, this is 31. What is our mean? Our mean is 3.5. It is what? The leg or the altitude? So if it's the altitude, it's going to go in the mean position of our proportion. What goes on each side? The segments of the hypotenuse, x and 1.84. So someone hopefully has a calculator. 1.84x is equal to 3.5 times 3.5. What's 3.5 times 3.5? Okay, hold that, 12.25. Then what do we have to do? Divide 12.25 by 1.84. And what is that going to be? 6.657. So this is 6.657. Now this rock figure is this whole length. So the figure is not 6.657 meters tall. It's not 1.84 meters tall. What do you do to get its height? Add them. So you're going to take 6.657 plus 1.84. So that's going to be 8.497. And meters is like 3 feet, and that's something that she wouldn't have been able to literally measure from height. All right, so let's see what your lesson is today. Your lesson is working with similar figures and when there's a side parallel. If a line is parallel to one side of a triangle and intersects the other two sides, so this is parallel, it intersects the other two sides, it does not have to be at the midpoint, then it divides those sides proportionally. Trevor, you want to get paper out to take notes? Take notes? Mm-hmm. Did you take notes yesterday? Good. Take notes today, too. Now, we're going to go down memory lane. If I have two parallel lines, what should we be able to find? Pardon? If we have parallel sides, or parallel lines, let's talk lines. If lines are parallel, what all sorts of things should you be able to find? You used it for congruence. Mid-segment, if this was a midpoint, but it's not. The F. Do you see an F? This angle is congruent to this angle. This angle is congruent to this angle. What kind are they? Corresponding. What do you know about this angle and this angle right here? Where they form? Same side, therefore they are 180. They're supplementary. So just because, do you see two triangles here? Can you visualize two triangles? The little one is easy to see. Do you see the big one? If two pairs of angles, if the two angles in one triangle are congruent to two pairs of angles in the other, what do we know about these two triangles? They're what? Similar by angle, angle. So normally, if I told you this was 4, and this was 3, and this was x, and this was 5, before we have what is above, we would say little triangle, little triangle. Then we would say, how long is this side? 7. How long is this side? 5 plus x. And we would say 4 corresponds to which one? 4 is little, x is little, I put little on top. 4 corresponds to what in the big? This is the side of the little that 4 is. What does it correspond to in the great big one? 7, this whole side. And x, this little side corresponds to what? 5 plus x. Okay, that was before this. What this is telling us is that if we have a parallel line, these are proportional themselves. So I can say 4 is to 3. 4 is to 3 as, what do you think this side would be? I heard it. X is to 5. It wouldn't make sense to say 5 is to x. 4 is coming from here, so x would have to. Then we've got 3, which is easier to solve, the bottom one. But it's only because of that theorem. So then we would say 3x equals 20. X equals 20/3. So that's what that side would be. We would get the same answer. When we do this one, we'd have 7x equals 4 times 5 plus x, which is 7x. Distributing, we get 20 plus 4x. Subtract the 4x. Do I get x to be the same thing? I do. But what must be true to set up our new proportion? What must you see? Parallel sides. Okay. So, how do you suggest we set this up? Nick, let's find A. How do you find A? Okay. Now, these aren't means now, like yesterday. So, what do you want to start with? Okay. So, if we're going to do 2x plus 6, do you agree that this is a whole side? Okay. What does it correspond to in the big? X is an angle. This that's not marked. Okay. So if I put, I don't know why I put 2. Let me put 2x plus 6 on the top. 2x plus 6 in the little triangle is to y in the big triangle. Now, what is a side in the little? Now, I need a whole side in the big, not part. Yes, we'd have to do 8. There is not an option here. All right? And the reason why there's not an option is because this is a whole side. So because that is a whole side, I'm going to have to do whole side on everything. This is not solvable right now because we've got 2 variables. So we'll put that on hold. What's another proportion I could write? If I start with 3, 3 is to what? What did you say? Did you say x or a? So if we say 3 is to a, then what are you going to say? 5 is to 7. That works. What else could we have done? We could have said 3 is to 5 as a is to 7. This cross product is 5a equals 21. Notice this cross product is still 5a equals 21. So 3 is to a as 5 is to 7. 3 is to 5 as a is to 7. Either way, you're going to get to the same point. So A is going to be 21 over 5. And I don't know how we're going to get X. I don't think I wrote a very good question here. I think all we're going to be able to find is Y. Is A. Because I would need to know X, and there's no way we're going to know this angle because I didn't give you that angle, and it doesn't make sense the angle would be part of that. So that's as far as we can go on this problem. But this is a correct proportion. And they may do this to you in the textbook. When you're on this whole side, this proportion taking pieces of sides won't work. Let's try another one. All right. So what do we know about these angles? Bree? Lines are parallel. So what kind of letters should you be looking for? What letters are associated with our parallel lines? Pardon? Yeah, you do. When we have parallel lines, remember all those letters we had? Z's? What other kind of letters? F's. Is there an F there? Okay, this line's parallel. This line's parallel. This is the transversal. Do you see the F? What do you know about those two angles then? Yeah. So we'd say y plus 8 equals 6y minus 27. This goes back to Unit 1. And what's nice about this is it keeps it current in your minds because you're going to need this for the EOC. Kayla E., what are we going to do from here? How? So I'm going to subtract y. So I'm going to have 8 is equal to 5y minus 27. Then what? When we add 27, we're going to get 35 equals 5y. So what does y equal? 7. All right. So what proportion can I write now? Brittany N? I've got this information here. I've got this, and this, and this, and this. What kind of proportion could I write?
D equals 3
Mm-hmm.
over 12
Over 12.
and 6 over 7.
Excellent. We could have done D plus 3 over 6 and 12 over 7, however you see that. We're going to work with this one. We're going to start to solve this. We're going to cross multiply. Notice that I don't try to distribute. I'm just multiplying. I'm just showing it so that I don't mess up my distributing. This is 7D plus 21 equals 72. What do I do next, Hope? So I'll subtract 21. So I'll have 7D equals 51. What do I do next, Kayla S? And we'll get 51 over 7. Do you like today better than yesterday? Yeah? Do you like today better than yesterday? This is the last section, by the way, before your next test. So we have a test coming up. So what is today? Tuesday? I'm pretty sure. I'd have to look, double check. All right. How are we going to find x? What's the relationship between those two angles? Same side. What is same side? They add to 180. I do partial credit, and then that's how I get the total. You know, for years I was stuck with that 100. And I tried to fit partial credit into that magical number 100. And then someone said, why do you have to have a magical number 100? Figure out what you want to do for partial credit, add it up, that's good. That's
It's just like boring when you see it. It's like if you did all right, but then you have to subtract 5 points from it.
No, you just do that number divided by whatever is there. So this is 60, this is 1. You are geometry. You can do the arithmetic. All right, I need a proportion set up. Nick, you get to do it. You name it. How do you want to do it? 15 over 20 equals?
2x equals 5.
Excellent. So we've got 15 times 8 equals 20 times 2x minus 5. You're going to distribute 40x minus 100, and I don't know what this is, 40, 120? All right, what are we going to do next, Tommy? Add 100, we're going to get 220. All right, what are we going to do next, Caitlin? Divide by 40. You're going to get x is equal to 11 over 2. So I think we're going to take this and we're going to kind of grow it. We're going to expand it. Yes. An extension of this theorem states that if three parallel lines intersect two transversals, then the segment intercepted on the transverse, I can't say it, are proportional. Think about this. Is this not really an extension? Because if I were to extend this line and I were to extend this line, wouldn't eventually we make a triangle? So what we're saying is, if this is little a, oh, I need a pen. If this is little a, and this is little b, and this is little c, and this is little d, you could say a is to c as b is to d. You could say a is to b as c is to d. Do you see how it really truly is the same thing? So if BC is 9, DE is 12, AB is 6, and EF is 2x plus 1, what are we going to have? Karen, what proportion? 9 over 12? All right. And then you solve from there. So we've got to go into the angle bisector so you can do all your problems. AC this time, ooh, AC is 20, AB is X, DE is 12, and EF is 5. All right, who wants it? Harper, I want you to try this one. What proportion do you think we're going to set up now? 12 over 5 is going to limit me a bit because I need to know that and it'll be messy. What would you have let this be? Oh. And then we'd have a y and an x. Could you do this? What is that? Ah. So now could we say x over, you pick it. 5. All right, if I do x over 5, then I'm going to say 20 over what? Yes. Okay. So then we've got 17x equals 100. Did you all see that? If I'm given this whole, and you have numbers over here, get that whole. And then we can say part is to part as whole is to whole. And my guess is they probably did that. All right, so now we've got a triangle, and we've got this angle bisector. This is important. It must be an angle bisector. Bisector. Okay. So if this is A, and this is B, and this is C, and this is D, then what this means is A is to B as D is to C. What do we do? Can you make sure this is in the section? It is. Another way you could do this is you could say A, this side is to this side, but if you do it that way, then you've got to pick that piece to that piece. Are my cross products still the same? Angle bisector separates that opposite side into sides that are proportional. Let's do, suppose I tell you that this is 10, this is 4, this is 9, and this is x. What proportion could you set up, Travis? Ten over x is equal to 4 over 9. So then we would say 4x equals 90. We would divide by 4, and x is going to be 45 halves. They have to tell you that that's an angle bisector. But it separates your triangle into proportional pieces also. Any questions? Do you want me to go back to a question on the homework? Yes. 11 in the book? No, 11 on the worksheet? Worksheet? Okay, so if we look at 11, we've got a triangle that looks, oh, I gotta get out of this dotted line stuff. Okay, so this is what it looks like. And they told us that this whole thing is 8. They told us this is y, this is x, this is z, and this is 4. What's 1 mean, Bree? X is not a mean. 4, because it's a large leg. Okay, Kayla S., what's another mean? Z, because it is the altitude. So now we're going to go ahead and we're going to set up our means. And we've got 4 and 4. Okay, 4 is the geometric mean between what two pieces, Eric? We did this earlier. Yeah. We're on 4. X, yes? Whole hypotenuse. The altitude is the geometric mean between what, Devin? X and Y. Bree, then you solve. This would be 8x equals 16. X equals 2. If x is, yeah, I need your homework. If x is 2, then what's y? Yep, and now you can do this because x is 2 and y is 6. And then you're going to have z squared equals 12. And then you're going to square root both sides. And 12 is 4 times 3, and the square root of 4 is 2. I'll have to get you a new blueprint. Didn't you turn it in?
No, I like actually 4.
Oh. Okay. Yes.